Hello, everybody. Welcome back to Mathicist over here. I'm Coach Dalton. In my previous video, I talked a lot about this trig thing that the SAT's been totally obsessed with the last few years. Sine of x is equal to cosine of 90 minus x. So if you haven't watched that video, highly recommend you check that out. Right now, I want to go through a few SAT problems that deal with this issue and show how we use this concept in the wild, so to speak. One thing I love to say about this concept is it's basically the only weird trig thing that they care about. It's the only thing that's more complicated than super basic stuff like SOHCAHTOA or the unit circle. So, what that ends up meaning for us is if you're ever on a question that is about sine and cosine, but it seems to be a little beyond the basics, like SOHCAHTOA is not cutting it, or the unit circle is not enough to answer the question. What I highly encourage you to do is assume that it's testing this rule, that sine x equals cosine of 90 minus x. This idea that when two angles add up to 90, what it means is that the sine of one angle is equal to the cosine of the other. So just assume any weird trig question is testing this idea. See if you can figure out how it's testing it, but even if you can't, just assume that the angles add up to 90. Or assume that the sine of one angle equals the cosine of the other. So I just want to really emphasize that over here. Let's get into some problems here. Here's the one that started it all. In a right triangle, one angle measures x degrees, where sine x equals 4 over 5. What is cosine of 90 minus x? I'm just going to show you how we can derive this idea, but we all know what the answer is going to end up being, right? They tell us sine of x. They want to know cosine of 90 minus x. Well, what did we just say? We just said that sine x equals cosine of 90 minus x. We know the answer is going to be 4 over 5. But let me just show you real quick why that's true. Let's just draw a right triangle. This would be a decent way to start a problem like this if you didn't already know this rule. They mention a right triangle, so let's go ahead and draw a right triangle. They say one angle measures x degrees, so let's pick an angle to be x degrees. I picked that one. We could have picked either one of these two, right? Obviously, we're not picking the right angle. You know that, right? Sine is opposite over hypotenuse, so the opposite side from x is this side here. So I'll label that 4. Hypotenuse I'll label 5. And now they want to know the cosine of 90 minus x. Well, all three angles add up to 180 because it's a triangle, and that's how things work. It's a right triangle, which means this angle is 90. So the other two angles add up to what? 90, yeah. So if this angle down here is x, well, it means that this angle over here is 90 minus x. So when they say x and 90 minus x, I think a more helpful way for you to think about that is one angle and the other angle, as far as the other two angles are concerned in a right triangle. So what's the cosine of this angle up here? Well, cosine is adjacent over hypotenuse, 4 over 5, which we knew that was going to be the answer, but I just want to show you why that is. The sine of one angle is always going to be the cosine of the other, because one angle's opposite side is the other angle's adjacent side. Okay, so we got that sort of taken care of here. This is one basic example of where you might see this problem show up, but you'll see they have very creative ways of testing this concept. Let's check out this next one. If sine x equals a, which of the following must be true for all values of x? Well, this is not a very creative way of testing this, but hey, whatever. Look, what are we talking about right now? We're talking about this, that sine of x is always equal to cosine of 90 minus x. That's just a thing, okay? That's just a thing. Get to know it. Love it. They tell us sine x is a. Well, that means that cosine of 90 minus x is a. That's the whole point of this rule. This ended up being not really that creative way to test it, huh? Let's keep going and see what's next. In triangle ABC, the measure of angle C is 90 degrees. If sine of A is 3 over 5, what is cosine of B? Let's go ahead and draw this triangle out, but I bet you already have an idea of what's going to happen here. So let's label this. They said angle C is the 90. I'll just make this up here A, and down here this is B. Let's see. They said sine of A is 3 over 5. So that means that opposite over hypotenuse, opposite of A is 3, hypotenuse is 5. What's the cosine of B? Well, adjacent over hypotenuse, 3 over 5. But honestly, I don't even know why I drew this. I mean, who cares? Angle A is one angle, angle B is another. The sine of one angle is the cosine of the other angle. So if sine of A is 3 over 5, then the cosine of B is also 3 over 5, okay? Ugh! Okay, moving on. In right triangle XYZ, sine of x equals cosine of 20 degrees. Okay, so what is the measure in degrees of angle x? This one's a bit more creative, I guess, so we can give them some more credit here. Look, this is something that I really want to emphasize over here. That part of what this rule is about two angles that add up to 90. When two angles add up to 90, it means that the sine of one angle is the cosine of the other angle. We already established that, right? But it also goes in the other direction, okay? You know what I mean by that? What I mean by that is that when the sine of one angle equals the cosine of the other, it means that they add up to 90. So if they tell us that sine of A equals cosine of B, if sine of A equals cosine of B, well, that means then A plus B equals 90. Okay? So back to the actual question here. In right angle XYZ, if sine x equals cosine of 20, they're telling us that sine of one angle, x, equals the cosine of the other, 20. So what does that mean about those two angles, x and 20? It means they add up to 90. So what that means is x equals 70. Okay? Oh, now we get to some real stuff here. This is admittedly a more creative way to test this. One thing I like about this question is it doesn't even seem to be about triangles, right? It's mentioning sine and cosine, but it just shows two angles. Even says they're not drawn to scale. My goodness. The angles shown above are acute. Okay. And sine of A equals cosine of B. Sine of A equals cosine of B. So right away, what does that tell us about those two angles? If A equals 4k minus 22 and B equals 6k minus 13, what is the value of k? This is such a classic question that makes people freak out. But can we just focus on this thing they told us? If sine A equals cosine of B, what does that mean again about those two angles, about A and B? It means they add up to 90. Because that's how things work, okay? It doesn't matter that there's no triangle here. It doesn't matter that there's no right triangle here, or they didn't mention a right triangle. I know that you're all freaking out because, oh wait, doesn't sine mean hypotenuse? Where's the hypotenuse? No, okay? Calm down. They're just saying sine of one angle equals cosine of another. And we know, you better know by now, that what that means is that the two angles add up to 90. A plus B is 90. So if they've told us that A is 4k minus 22 and B is 6k minus 13, well, all we gotta do is do 4k minus 22 plus 6k minus 13. And we set that equal to 90. And we can solve for k like that, right? Because 4k minus 22, that's A. They told us that. 6k minus 13, that's B. They told us that. We know that A plus B is 90 because they also basically told us that, right? They told us that when they told us that sine of A equals cosine of B. I'm not going to solve this equation. You can do that. Okay. Here's another fun creative thing. Is this like the last one, by the way? Yeah, this is our last one. Why don't you go ahead and pause, see if you can solve this one? I mean, I should have said that at the beginning, right? I mean, like, let's face it, like you should always be doing that. In fact, you shouldn't need me to tell you that. You should always be pausing and trying to solve problems on your own. You're trying to get better at this or not? Jeez. Okay. In triangle RST above, point W, not shown, oh no, lies on RT. What is the value of cosine of RSW and sine of WST? What a good example of a weird trig question, right? The kind of question that they ask us this, the unit circle doesn't seem to be helping here. The SOHCAHTOA doesn't seem to be really helping out. And I really want to go back to this idea that when that happens on a trig question, when the usual tools, SOHCAHTOA and unit circle, are just not enough, you can basically assume that it's testing this rule. That sine of one angle equals the cosine of the other when the two angles add up to 90. So, even if you can't figure out how that rule applies, just assume the two angles add up to 90, or assume that the cosine of one angle equals the sine of the other. If this cosine of this equals sine of that, if these two things are the same, what would one minus the other one be? If they're the same, and you do one minus the other one, it'd be 0. Right? So you see how even without really understanding how this rule applies to this particular question, without even bothering to try, we can make that assumption and still get an answer? I really want you to start doing things like that. This is a test of will and courage in a lot of ways, not just math. But let's just go ahead and see what happens. And if we go through this question for reals, point W not shown lies on RT. I'm just going to pick a random point here to be W. And the value of cosine of RSW. So I'm going to draw a line there because RSW They're talking about that angle RSW, so that's this one here. And they're talking about the angle WST, which is this one here. What do you notice about those two angles? What do they add up to? They add up to the right angle that was labeled there, a 90-degree angle. So these two angles add up to 90. So what does that mean? That means that the cosine of one equals the sine of the other. So they're the same, so one minus the other one's going to be 0. I mean, we already knew that was going to happen. Well, I guess we didn't know, but again, it's the only weird trig thing they test. So if SOHCAHTOA and the unit circle are not enough, just assume that it's testing this. And assume that the cosine and the sine are equal. Or assume that the two angles add up to 90. Whichever assumption helps you get an answer down. Give me a subscribe. Give me a like. Check out my subreddit Mathikists. Apply to work with me, Coach Dalton Foster at gmail.com. I'll see you in the next one. I think I'm going to be talking about triangles all week, so we'll see.